Okay, so today we are looking at the halogens. So we're going to be starting off with their properties, their colours, and figuring out where does that colour come from, displacement reactions and what a displacement reaction is, and finally some exam style questions. So let's get started with the properties of the halogens. So we will be looking at it as we go down the group. So the same with group 1, we're going to be looking at how the properties change as we go down the group, and here are the halogens. So what do we have? So our first one is increasing in density, and same as before with group 1, we're getting an increase in density because we're getting a bigger mass number. So there's more nucleons in the nucleus of the atom. So if we have a quick look, so with fluorine, in fact, actually, first of all, we should definitely state that all of them exist as diatomic molecules. So you find them as diatomics, and this is because it gives them the full outer shell, which all atoms are after, so they covalently bond and then they have a full outer shell. So so fluorine would have a mass of 19 times 2, so that would be 38. And then acetine would have a mass of 210 times 2, so that's going to be 420. So so this will be 38, this would be 420. So we can see that's a big difference, a huge difference between these two. And I can put the units in, so grams per mole, grams per mole. So a huge difference between the top and the bottom of the group. And even though they are kind of getting bigger because their atomic radius is getting bigger, it's not getting comparatively bigger considering how heavy the molecules are becoming. Okay, and this is kind of also explaining our second point. So our second point is looking at an increase melting and boiling point. And this is because, again, they have a bigger mass number. And this is to do with, the intermolecular forces. So if we draw a few fluorine molecules, and if we draw a few acetine molecules, so in like very simple diagram form, if you've got circles attaching, that means they are bonded together. And then we've got, they're a little bit bigger than the fluorine. So the interactions between these molecules, called the intermolecular forces. And the intermolecular forces between fluorine, we draw intermolecular forces kind of like this. The intermolecular forces between fluorine are much, much weaker. And it's because this is a much smaller number. So the intermolecular forces increase with a larger mass number. So these intermolecular forces between the acetine are much greater compared to the fluorine, and again it's all linked to the mass number. And we can see this in the trends in the melting and boiling points. So we start off with gases, so fluorine and chlorine are gases, then we end up with a liquid, and then the bottom two elements are a solid at room temperature. And our final thing, a decrease in reactivity. So as we're going down the group, we're having a decrease in reactivity. So fluorine is the most reactive halogen, with acetine being the least reactive. And this is due to how hard / easy it is to gain a full outer shell. So with fluorine, because fluorine is a smaller atom, to gain a full outer shell, it just needs one electron. So it's a lot easier for fluorine's positive nucleus to kind of attract the one electron that it is missing. Compared to iodine and acetine, its outer shell is much further away from the positive nucleus, so it's much harder for it to hold on and attract the electron that it is missing. So kind of the opposite reasons why reactivity of group 1 is increasing as you go down the group. So the bottom of group 1 and the top of group 7, those are the two of the most reactive elements on the periodic table. So so francium and fluorine. Okay, so on to the halogen colours, and we can also explain where the colour is coming from. So these are things you just need to know. So let's just go through them one by one. So so fluorine is a pale yellow gas. And again, this is a lovely AI image. So didn't quite get the gas right, but we can imagine that this is a gas, this is a gas. So fluorine is a pale yellow gas, chlorine is a pale green gas, bromine is this lovely orangey brown liquid, and iodine is a grey solid. So this is at room temperature, so iodine is a grey solid. But what we haven't taken into account, and yeah, this is also worth knowing, is that a lot of the time when you see iodine, you see it in solution form, and yet iodine has this lovely, very distinctive purple colour when it is in solution. Okay, so on to where does the colour come from? So the colour comes from the existence of the bond between the halogen. So we've got fluorine here, so yeah, so fluorine is, for the fluorine molecule, is two fluorines bonded together, and the colour is coming from the existence of this bond. So what's happening is this bond kind of interacts with light, so white light. So white light comes along, and so your white light comes along, and some of the frequency of light is absorbed by the bond, and then yeah, what we observe is the colour green, or sorry, yellow with fluorine. And then yeah, with chlorine, it's the pale green, bromine, it's the orangey brown, and yeah, iodine, it is yeah, that grey colour. So as soon as, if that bond doesn't exist, then the molecule loses its colour. And this is really important to remember when we look at our next thing, which is yeah, the displacement reactions. So we really need to remember that the colour and the existence of the colour is because of we have the bond. So yeah, so on to yeah, the displacement reaction. So first of all, we've got our definition here. So a displacement reaction is when a more reactive element displaces a less reactive element from a compound. So you kind of compare the reactivities between the two elements, and then if the more reactive element is not in the compound, it displaces the element out of its compound. So here we have a couple of AI generated images that we will talk through. So we'll talk through the better one first of all. So this one has got an equation, but what's going on here is pretty weird. So what is going on? So we've got chlorine, and we can see chlorine is this pale green colour. Potassium bromide has no colour. So because there's no halogen bond, this is it's either a white solid or it dissolves to give you a colourless liquid. So we've got our colourless liquid here. And then what is getting formed is we're getting some bromine getting formed, so that's why we're getting this orange colour here. And then yeah, the second product is potassium chloride, again without any colour. So yeah, so when you add the chlorine, it's reacting with the potassium bromide. Chlorine is more reactive than bromine, so it is displacing it out of the compound. So we're left with yeah, the bromine, which is why we've got this colour here. And yeah, the potassium chloride, which is now the new colourless solution. So let's have a look at what we've got going on over here. So we've got this greenish sort of thing. So this could be chlorine. So we've got chlorine over here. We've got this orangey brown thing over here. So we're getting bromine getting formed, which makes sense. Chlorine is more reactive than bromine. And again, it would be the same reaction over here, but AI this time didn't do a particularly good job of making the image. So let's have a look at a few more examples. So yeah, so we've got fluorine. So yeah, so fluorine is the most reactive halogen. So fluorine could displace any of the other halogens out of their compound. This time it's displacing chlorine. So yeah, so fluorine is pushing the chlorine out, getting a new compound formed, and then yeah, we're getting chlorine getting made. So with this one, what would we observe? So we would have a pale yellow gas would change into a pale green gas. Here we've got bromine and iodine. So we can see, yeah, this is going to react because bromine is more reactive than the iodine. So this is pushing the iodine out. So what would we observe this time? So we would start off with the orangey brown liquid. And because this would be in solution, would end up with a purple liquid. So there we go. Okay, on to our exam style questions. So let's see how many you have for you today. Wowzers, trousers, there's 8 questions, but yeah, I'm not going to do all of them. So yeah, I'm going to do the first few for you. But if you want any clarification or the answers, then I will give those to you in the comments. If you comment and want an answer, I will reply to your comment and give you the answer. Or if you want even more chemistry help, then you can have one-to-one chemistry tuition with me. All the details about that are on my website, and yeah, that link is in the description. So let's have a look at these first two questions. So state the physical states and colours of chlorine, bromine and iodine at room temperature. So we have done this quite a lot already, so this is good. So chlorine is a gas, so it's a pale green gas. Bromine is a liquid, it is a reddish brown liquid, one of only two liquid elements on the periodic table. Mercury is the other one. And then your iodine is a solid, and it is a grey solid. So yeah, so you really do need to know the colours, especially of these three elements. It comes up lots and lots and lots. And what do we have here? Well, apparently we've got the word colour spelled incorrectly, but we can move past that. So predict the physical state of acetine, which is at the bottom of the group. So yeah, so acetine doesn't usually get spoken about too much. So acetine is going to be a solid. If iodine's a solid, acetine has to be a solid. And what colour could it be? Well, the colours kind of do increase in intensity as we go down the group. So what's a more intense colour than grey? Well, it's probably going to be black. So it's going to be a black solid. Okay, and then the final question that I'll go through, and then I'll leave the rest to you. So describe the trend in reactivity of the halogens as you move down group 7. So the trend is they increase in reactivity. So we're only describing, this is really important, with answering the question, we're just describing, and yeah, the description is an increase in reactivity as you go down the group. Now on to explaining. So explain in terms of atomic structure why this trend in reactivity occurs. So it is because at the top of the group, it is easier for those elements to grab onto the electron that they need. But as you go down the group, it is harder for the elements at the bottom of the group to obtain the electron that they need. And this is because it is just further away from the nucleus. The outer shell is further away from the positive nucleus. Okay, so there we go. So I'll leave the rest of the questions for you. And yeah, thank you for watching. If you enjoyed the video, please do tell your chemistry class, and yeah, remember to like and subscribe. All right, I'll catch you in the next one. Ciao, bye.